Hello and welcome to our channel. In this video, we will talk about dynamic memory allocation. Let's say we declare an array of size 5. Now, what happens in the memory is it creates space for 5 elements. And let's say we want to insert 3 elements here, 4, 7 and 5. Now there is 2 extra spaces remaining. If we take another case where let's say we want to insert more 3 elements 1, 3 and 9. Now there is no extra space here. In this case there is wasted space, and in this case there is no extra space, and the program will halt due to error. To tackle this problem, we use dynamic memory allocation, which allows the user to set the size of the array during runtime according to their needs. Let's try creating an array first. Let's say integer a of size 5. I will try to insert 7 elements here. Integer I equal to 0, I less than 7, I plus plus. I will set a of I equal to I, and let me save this. I will compile and I will run the code. Now it gives me an error which says stack smashing detected, which means there is no extra space left. To tackle this problem, we will use dynamic memory allocation. For that, we need to use another standard library which is stdlib.h, and we will change this array to a pointer, and we will write a malloc keyword here. Inside the parameters, we want to give the size. Since we want to store integer elements here, we will write size of int, which will return the size of integers, which is 4 bytes. Let's say we want to store a number of elements. Then let's say the number is size. We will create a new variable size is equal to 5, and we will simply multiply it with the size of integer. And here we also need to typecast it to the required variable. Since the variable type is of integer pointer, we will write here integer pointer. And now we will change this to size. We can save this, we compile and run, and we get output with no errors. We can also print this thing. I will change this and insert printf I'll write here %d space, and here I will write printf /n. I will save, I will recompile and run this, and we get the desired output with no errors. Let me try changing this. Let's say the size is 50. We'll save this, we will recompile and run, and we get the desired output with no errors. We can do similar things with structures also. Let's say we have a structure called point. Here we will say integer x and integer y. We will change this type to point. We will change this also to a point, and the size of to point. And we can remove this part, and we can say here You can move the size also. And we can say a of x is equal to 20, a of y is equal to, let's say, 30, and we can do a printf here. Let's say x is %d, comma y is %d. Here we will write a of x and a of y. We'll save this. We can recompile. Okay, we got an error. We'll put an arrow here. We'll save this. We will recompile and run, and we get the desired output. After creating the element, we need to free that memory. For that, we can use the free keyword, and inside this we can write a pointer. We'll save this, recompile and run, and everything fine. Now this dynamically allocating memory will help us create more data structures such as linked list, which we'll see in the next video.